Hello grade 12, we will continue working on chapter 3. So we explained chemical bonds between atoms and intermolecular bonds between different molecules. So today we will explain resonance structures. Resonance structure is a possible or the possible Lewis structures that can represent a molecule. The most famous one is benzene. So in sulfur trioxide first, it is just the moving of the double bond. Okay, so all these Lewis structures are the same except the placement of the double bond, and they are all possible, so we call them resonance structures. So in benzene we have 6 carbons, and between them 3 double bonds and 3 simple bonds. So the best way, maybe you have seen it, to represent benzene is that we draw this polygon with 6 sides and then a circle inside. Okay, because the double bonds will move and will keep moving. It's not just how we represent it. Inside the molecule, chemically, they keep moving. So this is why usually we draw benzene in this way. So for the geometry of the molecules, we will go directly. Let's go to the table so you can read those. Take a look at them. Vesper and molecular geometry, and here is the table to study. So, in short, the geometry or the shape of a molecule depends on the atoms bonded to the central atom and the lone pairs of electrons on the central atom. So يعني in most molecules, or the molecules that we will study its geometry, we have one central atom that we will label A, and we have atoms attached to this central atom that we can label X. Okay, so the central atom is A and the atoms attached to it is X, and A might have lone pairs of electrons. For example, oxygen, this is the Lewis structure of oxygen. So if it is the central atom, so let's take the example of water, H2O. So it has 2 lone pairs of electrons. So electrons E, it has 2E. Okay? And in this case, 2 peripheral atoms, or atoms bonded to the central atom, so it is A, X2, E2. Okay? And we will see how, what is the shape of each one. So we will use the letters A, X, and E. A will be the central atom, X will be the peripheral atom or the atoms bonded to the central atom, and E is the lone pairs of electrons on A, on the central atom, okay, not on the peripheral atoms, of course. Now, the easiest form is AX2. So it's not written, an example is given and the numbers are given. However, this is not written. I advise you to write these. You can copy the table, okay, on your a notebook to study it. So if we have AX2, a central atom that does not have electron pairs, and there are 2 atoms attached to it like BeF2, its shape will be linear. Okay? In this case, AX2E or E1, so like SnCl2, but Sn has 1 pair of lone electrons, the shape will be bent. Okay? And AX3, the shape will be trigonal planar, like this. We call it trigonal planar, like BF3. In the case of AX4, it's tetrahedral, like CH4, 1 central atom C and 4 peripheral atoms attached to it. In the case of AX3E, like NH3, but there is 1 pair of electrons attached to nitrogen, the shape is also trigonal, pyramidal, so it's different from the trigonal planar. In the case of water, so it's AX2E2, as we have seen before. It is bent. and in the case of AX5 like PCl5, it's trigonal bipyramidal, two pyramids, and AX6 is octahedral. Okay, so to get more information you can read the previous pages, and I advise you to read them and to study this table. Okay, good luck.